Yes, guys. So we are doing question number 10th. Now, 10th question says that discuss the position and nature of double points on the curve x4 plus 4ax cube minus twice ay cube plus 4a square x square plus 3a square y square minus a4 is equal to 0. Okay, this is the equation. The position of the double point, what kind of double point is there? Okay, it's on the position and nature of the double points on the curve. Okay, this is the question required. Now let me, okay, I've written down here. This is question number 10th here. Sorry. Okay, so question number 10th. Now let us continue. So solution. What do we find out solution? For the nature of the double points, what we do, we just find out differentiation, partial differentiation, or let us consider this equation as fx by, let fx by is equal to this x4 plus 4a x cube minus twice a y cube plus 4a square x square plus 3a square y square minus a4, okay, which is equal to 0. Now differentiating them, okay, but for finding the double points, we have to find out del f upon del x, del f upon del y, and f equal to 0. From this solution, we will find out what are the double points, kinds of double points, how many double points are there, out of them, which are which are proving this, I mean, which are possible double points that we will select out of the points here. I think this is a lengthy question, so number of points may be there. Okay, out of those double points, we have to select the right one, which is satisfying this equation given, this equation of the curve. If it's satisfied by those points given, then we can say that, okay, this is a double point here. Now let me differentiate them. So what is del f upon del x? Differentiating with respect to x and y respectively. Okay, so partially we are differentiating. This is partial differentiation. Okay, so del f upon del x is equal to, this is 4x cube plus this is 4 3 are 12 a x square, this is 0, this is plus 8 a square into x. Okay, so this is one equation. Now del f upon del y, let me find out. It will give us these two are zeros, because differentiating with respect to y means only this function will be differentiated, and second is this one, this will be differentiated. So these two steps are there, so that will be minus 6a into y square, this one, and second is plus again 6a square y. Okay, so this is, let me take this as first equation, this is the second equation, and equation of the curve, if I take this as the first one, no problem, this is second one, and this is third one. Okay, now again let's find out double derivative, because we have to prove for double points to be a cusp, to be a node or a conjugate point. What we do, we find out b square minus 4ac, which I proved in the beginning, that there is a condition that if the given points are forming a cusp, double point is a cusp or a node or a conjugate point, that conditions are that b square minus 4ac, that means del square f upon del x del y whole square must be greater than del square f upon del x square into del square f upon del y square. If greater than this, then it will represent a node. For cusp, these two are equal. If for conjugate point, this b square is less than 4ac. Here 4 was cancelled out, so only del square. I'll just write the conditions, but before that let me find out the double derivative of these two. So differentiating further, and del square f upon, let me take further differentiating with respect to x here. This will be 12x square, first one, plus this is 24ax plus 8a square only. Okay, this is, let me take the fourth equation. Again differentiating with respect to y here. Del square f upon del y square. Del square f upon del y square, this one. It will give us minus, okay, 12. This is a y plus 6a square only. This one is, let me take fifth equation, equation number 51. Okay, now okay, one more. This is del square f upon del x del y. It means this function which is with respect to y already, this one, third one we have to differentiate with respect to x. So it will give us del square f upon del x del y. This is del f upon del y. If I differentiate this function with respect to x again, but these two terms are without x, so it will be 0. Okay, so we have to prove that what is the condition del square f upon del x del y, this whole square, is it greater than del square f upon del x square into del square f upon del y square at the given points. So whatever the condition, or equal to or less than these three conditions, this will denote a node. This is for cusp. The point will be a cusp, and the point will be a conjugate point or isolated point for this condition if this is lesser than this. First, let me find out the value of these on the given points. So how the points are calculated by equating this. So to find the points, to find the double points, what we do, del f upon del x must be 0, del f upon del y must be 0, and f equal to 0. So what does these equations get? Let me check that. If I equate this second equation equal to 0, so what does that give us? Let me check that. Okay, so this implies that the second equation equal to 0, that means 4x cubed plus 12ax squared plus 8a squared x, okay, equal to 0. Okay, taking common here, so 4 x have to take common because x is throughout common. It will be x squared, first step, plus 4 3 are 12a into x only, plus this is 8a squared. Okay, now we have to factorize this. So factorizing 8 in such a way that the values of these functions will be what? So this is a quadratic equation here. So let me check that what quadratic equation does show. So this is 8a square. Okay, not a perfect square, but let me find that what is the condition. Okay, so sorry, I'm sorry. I've taken 4 common here, so this is 2, I'm sorry. This is 2 here, I'm sorry. Now it's okay. So 2 and 1 are the factors of this function, 2a square. So if I factorize 2a square, so that this can be obtained, so x square 2a square, that means 2a plus 1, that will give us 3a. Alright, so 3ax can be obtained, so this is equal to 0. So from this x equal to 0, it is giving us x equal to 0, and from these two equations, what are the factorization of this function? This will be x squared plus 2ax plus ax plus 2a squared equal to 0. If we take common here, here it is x common, it is x plus 2a. Okay, x common, x plus 2a, and from this a common, this is x plus 2a equal to 0. So x equal to, from this minus 2a, x equal to minus a. This is minus a and minus 2a. There are 3 points, 3 values of x coordinate, 0, minus a, and minus 2a. Okay, now if I equate third equation equal to 0, del f and del f del y equal to 0, imply that, and del f del y equal to 0, this one, it is minus 6a y square plus 6a square y equal to 0. Let me take 6 common, 6y common, 6ay common, 6ay common. So what we obtained, let me take first this one. This is only a minus sign. From this is y only, because this a y we have taken common from this a, and it is minus y equal to 0. So values of y are 2. What are those values? Y equal to 0, this equal to 0, y equal to 0, and a equal to y equal to a and a. What are those points? Let me write down those points now. Therefore, the points are, required points are here. I'm sorry, what are those points here? X equal to x was 0, minus a, and minus 2a. X was here, and y is 0 and only a, positive. Okay, so points are here. Therefore, double points, possible double points are. What are those double points? Possible double points. Therefore, possible double points. Double points are, first let me take x coordinates, so this is 0, 0, 0 and a. Okay, 0, a, 0, 0, 0, a, minus a, 0, then minus a and a. Okay, and now minus 2a, so this is minus 2a and 0, and minus 2a. A. Now we have to substitute these points in the given equation of the curve. If that is satisfied, that means they will represent double points. If they are not satisfying, then they are not representing the points. So if I substitute 0, 0, so from this equation, because minus a square equal to 0, minus a4 equal to 0, here it will not be 0. So 0, 0 is not the possibility. Okay, so 0, 0 is not the possibility. Then 0, a, let me take. Okay, so x is 0 here, 0, sorry, this one 0, 0. Y is a here, second point this one. Y is a, this is a4, minus 2a4. This is 0, and this is plus. Okay, 3a4, and this is minus a4, minus 2a4, maybe 0. So the second 0a point is possible. How? Let me check it. So substituting these values, these points, substituting these values in the equation of the curve. In the equation of the curve, let us find out whether they are satisfying or not. First, 0, 0 is not satisfying because a4 will remain, will not be equal to 0. Okay, this minus a4 will left open. 0, 0 is not satisfying. 0a, we have just tried that 0a is going to prove. Why? Because x0, x0, x is 0, a is, y is a. Y is a here. So, okay, so this is 0, this is 0, this is a cube, a4, minus 2a4, and minus a4, this is minus 3a4, and this will be plus 3a4, because y is a square into a square, a4, plus 3a4 minus a4 equal to 0. So this is fine. 0a is the first point. 0a, let me write here, 0a is possible double point. Is possible double point. What are the other points? Let me check. Other points, minus a and 0, let me check it, and minus 2a 0, sorry, minus 2a and minus and plus a. These points are coming out. 0a, the first point is. Let me put here minus a and 0. X is here minus a and y is 0. So these two terms are 0, y. Let me write here 0, 0. Only x is minus a. This is plus a4. Okay, this is minus 4a4. and this is 4a4. This is minus a4. So minus a0 is also coming out. So minus a0 is also possible because this is minus a4 plus a4 cancel out, and this is okay, x here 4a4 and this 4a4. This is negative, this is positive, cancel out. So these two are also cancelled out. So minus a and 0. So minus a and 0. This point 0a minus a0. Now minus a and a is not going to prove because this is minus plus a4. Let me write it minus a in place of x and in place of y is plus a. So this is not going to be proved here. Only minus 2a and a. This is possible. Minus 2a and 0 is not going to be proved. Only 3 points. We can substitute these points here and check. So which are the points? First 0a and third point is minus 2a and a. Let me check this also, minus 2a and a. Okay, so minus 2a and a, which also I have to prove. Minus a and a, minus 2a and 0, they are not points. They are not satisfying the given equation. How? For if I put minus a and plus a, because they are different values. This is x is minus a, so this is a4, a4 positive, this is negative plus a4, this is y is a here, so this is minus 2a4. So let me just check whether they are going to improve. This is positive, x positive, y is this 3, 4, okay, a4, okay, so this is 4 plus 3, 7, and here minus 2 and this minus a4, okay, and y is positive a. So this is 2a and 3a4, minus 3a4, and positive values are more. Sorry, this is also 7, this is 7 and this is 8. This is positive a4 and these 3 plus 4, 7. So 8 are positive and 7 are negative, but this 1, this 2, and this is 1 negative. 7 are negative. So this is second point is not there. This, sorry, minus a and plus a is also not there. Minus 2a and 0 is also not proving. Why? Because y is 0, minus 2a. This is 16, positive 16. Let me write here. Positive 16, a4. Here it will be, okay, y is 0. So, sorry, this is minus 2a. So 8 for the 32, negative. This is minus 32 a4. 0, this is also there. Minus a4 and this 4. 4 for the 16 here. This is positive 16. Plus 16 a4. But this minus a4 is also there. So these two are positive undoubtedly. These two are cancelled, but minus a4 is left over. So this is not going to be. So the third point, sorry, this one, minus 2a and 0 is also not satisfying. Only this point, this and last point. Let me take minus 2a and a. Minus 2a and a. So at minus 2a, these points have been obtained. At a also, in place of y, let me substitute. So these two terms will also come out. This is minus 2a4, and this is plus 3a4 because y is here plus a, and plus 3a4. Okay, so negative value is minus 3. These two are added in negative, and say 32 is this or this, so 0. So the last point, this one is also possible. Now let me check whether this condition is satisfied. So these points are going to prove. So minus 2a and a, minus a and 0 and 0 and a. So these points are double points, possible double points. Okay. So possible actual double points are these. So these are the possible double points. Hence, now let me check at each number. This condition is what? First of all, we have to find out the values of these 3 terms. This is 0, there is no change in this, but these two are to be found out with the help of these points. First is 0. At 0, first point 0 and a. What is value of del square f upon del x square at this point 0, 0? So 0 and a, this one. So x is 0, this is 0. This x is 0. And y is a, there is no y here. Only this 8a square. 8a square will be there. Because at 0, 0, x is 0. 0, 0, this 8a square is left over. Undoubtedly, okay. So this is value of del f, del square f upon del x square. What is del square f upon del y square? F point 0a, first point. It is a possible double point. So this will give us from y square this one. If I substitute 0 at x, so x is not there. Only at y we have a. At y this is a, this is minus 12a square plus 6a square, which is nothing but minus 6a square. Minus 6a square. The value of del square f upon del x square. Okay, del y square. If I multiply these two, what we see here, del square f upon del x del y whole square, which is 0 here. So what was this negative value, because these two are multiplied. This is greater than the negative value, which is 8, 6, 48 minus 48, a4. Undoubtedly, the first point 0a will represent a node, or will be a node. 0 is greater than minus 48, a4. Okay. In this way, first point 0a, the double point, will represent a node or is a node. Okay, so this point is a node. Let me write here. As the first condition is satisfied, this is greater than whole square of this is greater than, because this is 0, this negative value. So therefore 0a is a node. So this is representing a node. So this value is positive, showing a possibility of a node. 0a will represent a node. Now what about second minus a and 0? So at minus a and 0, let me check. Minus a and 0, x is minus a, y is 0. So let me take del square f upon del x square, del square f upon del x square. At this point minus a and 0, x is minus a, so it is giving us plus, because x square positive. It is plus 12 a square. This is minus, because x is minus a. This is minus 24 a square, minus 24 a square. This is plus 8 a square, positive. So what we obtain, 12 plus 8, 20, minus 4 a square. This will give us minus 4 a square. Del square f upon del x square at the point minus a 0. The value is minus 4a square. In this, if we compare, this is value minus 4a square. What about del square f upon del y square at this point? And del square f upon del y square at the point minus a and 0. This one. Sorry, this second. And here, y is 0, this is 0. This is positive value 6a square. 6a square positive, because this is 0, y 0, y 0. X is minus a, there is no x here. This will give us plus 6a square. Okay, so what we see, we multiply these two, del square f upon del x square into del square f upon del y square, which is positive, this is negative. So again negative, 8, 6, 4 is 24, 6, 4 is 24, minus 24a4. Again, and this is 0, del square f upon del y, del square f upon del x del y is 0. Therefore 0 is greater than, again, negative value. Hence, at minus a0, what do we have? Hence, minus a0 is also a node. Is also a node. So this is also representing a node here. Try to understand. This is a node, because this value is 0, this is greater than negative value. Okay, so this is minus a, 0 is also in node. These 2 points are node. Now let me talk about the last point, the third point, which was also possible, because this was satisfying the given equation of the curve. So minus 2a and let me take at minus 2a and a, minus 2a and a, what was the possibility? So del square f upon del x square, del square f upon del x square at this point minus 2a and a, let me write clearly. This is minus 2a and a. For the value of del square f upon del x square, which is this value, it will give us minus 2a. That means 12 4 is 48. This is positive 48. Positive 48 because 2a minus 2a whole square is 4a square, 4 into 12, 12 4 is 48, a4. I'm sorry, a square only. But this is square and this is a square. Positive 48 a square. What about this one? This is minus 2a. But there is no y here only. This is minus 2a, 48 minus 48. Again minus 48 a square. So this is 2a minus 2a. I substitute here in place of x is minus 2a, a into a square, and 24 into 2, 48, minus 48 a square, plus 8 a square, plus 8 a square as it is. Okay, this is value of del square f upon del x square at point minus 2a and a. Try to understand. This minus 48 plus 48 cancelled out, only plus 8a square. Okay, so this value is positive. So this is giving us 8a square, which is positive. What about del square f upon del y square at this point, which is minus 2a and a? This y square, del square f upon del square f upon del y square. This is the value. Now here y is a. So this is minus okay 4 48 and 24 48. This is plus a 8a square, and here y is positive a. So what was this point? Something mistaken or is okay. Positive 8a square. First one is, over here it is twice minus twice a, 4a square, 4 12 into 48. This value is. This is also giving the same thing, I think. What about this? Is it a same value or 0? Because it is 8a square. This 8a square is left over. Del square f1. Del square, this 8a square. This is 24. X, okay, and x square. 4th here 12 x square. So in place of x square, if I substitute minus 2a, this is minus 2a here and a. But minus 2a, it is giving us 12 into 4, 48. This is positive, okay. And this is minus here. Because negative minus 2a is there in place of x. So minus 48. A. So these two are cancelled out. So positive value, no problem. And third one, which we are calculating this y. Okay, so here y is a positive. So this is plus a. Y value is a. There is no x here. So positive value is a into, so minus 12 a square and plus 6a square. It will give us negative value. Again it is negative. Minus 6a because 12a square and plus 6a square minus 6a square, which is negative. Again this multiplication of these two numbers will give us negative value. Again it is negative. So this is again a node. It is not a conjugate point. We cannot say that this is a conjugate point. Because if it is negative value, and negative value is lesser than 0. Okay. Previously it was positive value. Previously they were this is negative value. So negative value is lesser than 0. Okay. So these multiplications, alright, this value is lesser than, so this negative value comes out to be 8 6 are 48 minus 48 a4 multiplication, a square into a square a4 and 6 into 8 minus 40, which is negative value, and here it is 0. 0 is less, not lesser but greater than, I think, or it is greater than negative value. Both are not negative. If both are negative, then it will be positive value, then it will be greater than 0. But in this case, again, the negative, this value 0 is greater than minus 48a. In first case, I am just surprised that this is not giving a conjugate point, because conjugate point only comes when this value is greater. 0 is lesser than this value is greater. Okay, so in this case also it's a node. Again, it's a node. So it's minus 2a and a, it is also a node. Okay, so all the 3 points are giving here nodes. In this way, because whatever calculation mistake if it is there, then we can just judge. Okay, so that is how we have proved here that these points at minus 2a, minus a0, this curve is giving us nodes. The double points are nodes here. All the 3 are nodes, no problem. This is question number 10. If there is calculation mistake, that can be improved upon, but concept must be clear. The concept is that double points we have to check, first find out the double points and then check what is the nature of them. If they are satisfying the given equation, then that will give us the possible double points. If those double points are representing a node or a cusp or a conjugate point, that we have to check. For checking that is the process. Now let me take next question, which is the 11th one. Here, 11th question. Again, determine the existence and the nature of the double points on the curve. This is also of the same type of. Here, let me take. So the equation of the curve here. The equation of the given curve is, what is the equation here? This is x minus 2 whole square equal to y into y minus 1 whole square. Okay, so again, let us take it as, because we have to find out the nature of the points. For finding the point, we have to find out del f on del x, del f on